Kirchhoffs' current law is also known as Kirchhoffs' junction rule. It's also known through a process that we call node analysis. Kirchhoffs' current law states that if you have a circuit, let's just say we have a circuit right here, power supply, and let's just say we have two resistors in parallel. So I will call this R1, I will call this R2. Kirchhoffs' current law states that the amount of current that we have flowing into any junction or any node. So if we have this node, this junction right here where these three wires meet, if I call this current I, and I call this current I1, if I call this current I2, it means that the total amount of current going into that junction, so I is going into the junction, that equals the total amount of current coming out of the junction. So that equals I1 plus I2. So simply put, I equals I1 plus I2 for this circuit that I have drawn right here. Current flowing in equals the amount of current flowing out. The idea behind Kirchhoffs' current law isn't really that new. It's really just looking at the law of conservation of charge. Since we know that the total amount of charge is going to be conserved, it means that in this individual circuit, the amount of charge that we have, the number of coulombs that we have, will remain conserved as well. And since current is just looking at coulombs per second, it's just the rate of flow of charge. We're saying that in 1 second we have a certain amount of charge going into this node. In that 1 second we have to have the same amount of charge coming out of that node. So because of that, that's how this Kirchhoffs' current law was developed. So it's really an important rule, and it's an important way to be able to do some circuit analysis later on. So if we start looking at some combination circuits, more complex circuits, you can use Kirchhoffs' current law to analyze that circuit because it's really just conservation of charge. So one of the things I really wanted you to understand is that these conservation laws, they're not just about energy, they're not just for lifting things in the air and throwing things and collisions, but these conservation rules, these conservation laws apply also to the small things. So law of conservation of charge is really Kirchhoffs' current law, so those conservation laws apply here as well. So it can also be applied down here at the bottom. So if we look at another junction down here at the bottom, it means we have I2 coming back into this junction, we have I1 coming back into that junction, so we have I1 plus I2. That means coming out of this junction must be a combined current. Since we already know that I is going into this node at the top, and that equals I1 plus I2, that means that I must be coming out of this, because that also is equal to I1 plus I2. So we've talked about how the amount of current flowing into a power supply is the same as the amount of current flowing out of a power supply. This is the reason why.